So we're given this equation and we want to solve for x. X minus 15 over 3x equals negative 4/3. Okay, so one possibility is just to start by eliminating the fractions altogether. So we're going to multiply each side by the LCD, or the least common multiple, of the denominators. So I look at them, 3x and 3, so that's 3x. And then I'd multiply the other side by 3x as well. Okay, now we're going to distribute. So 3x times x is 3x squared, and then we'll bring down that minus, but 3x times 15 over 3x, the 3x's cancel out and we're left with 15. And on the right, when we multiply negative 4/3 by 3x, the 3's will cancel, but we're still left with negative 4x. So now all of a sudden we have a quadratic equation. So we're going to try to factor if possible. But in order to do that, I need to move all terms to one side. So we'll add 4x to each side. And that gives us 3x squared plus 4x minus 15 equals 0. Okay, so you decide which method you want to use for factoring. I just used a guess and check method where the first terms, their product is 3x squared, and the last terms, their product is negative 15. And when you add the products of the outer and inner terms, you should get positive 4x. Set each factor equal to 0, and then solve each of these linear equations. So we find that x is 5/3 or x is negative 3, but we want to do a quick check to ensure we don't have any extraneous solutions, which are solutions that work in the quadratic equation but don't work in the initial rational equation. So first, substituting 5/3 for x in the initial equation, we're going to see if 5/3 minus 15 divided by 3 times 5/3 is equal to negative 4/3. So that's really 5/3 minus 15 over 5, or 3. And since 3 is 9/3, you could rewrite it getting a common denominator. 5 minus 9 is negative 4 over 3. So both sides are, in fact, equal to negative 4/3. And then we'll do the same thing for negative 3. So negative 3 minus 15 over 3 times negative 3. So that's negative 3 plus 15 over 9, or 5/3, is equal to negative 4/3. And you can see that we really have the same expression on the left-hand side. And so, yes, this solution also works.